Okay, so today we'll just look at two ways of visualizing simple and compound interest. Now this is not in sufficient detail what I am going to draw. It's an idea of how you can do it, and you can either do it carefully on a graph paper or you can do it in tools like GeoGebra. The first way to visualize simple and compound interest is that you have an original amount. Okay, and I am drawing it as a rectangle, but basically its length and a certain height. Let's say it's a unit height, so then the length represents the actual number. But even if you just make it as a rectangle, okay, it's a rectangle. So, and simple interest is that, let's say you have 10% of it. That means you're dividing this into 10 parts. Maybe I can use a different line for it. Okay, fine. Assume that that's 10. So, and then you're taking one of these parts, right? And each year you're adding that part. So in the first year you add this. In the second year you add this. In the third year you add this, and so on. In the fourth year you add this. Okay, so this is basically simple interest. You take your principal, make it flat, take a rectangle, cut out a part of it and keep adding that part. Okay, so that's a simple interest. What's compound interest? Compound interest is you take the same slab. So I'm starting with the same, right? And let's say you say the same 10%. So 10% means 1/10 of it. So let's say around this much is 1/10 of it. So the first year you say, all right, I'm going to add that part. Okay. And then the second year you say, okay, I have 10 of the whole. So which is going to be a little more, right? So 10 was this already, and maybe a little more than that, because now you have 10 of this also. So that's a little more. So it's a little longer. I'm not drawing it accurately, I may be even exaggerating to make my point. Anyway, so you have to do it yourself. Then you have to take 10% of the whole, which means definitely it's going to be this, and it's going to be a little more. And then you take 10% of the whole. So it's going to be this and a little more. So every time I'm adding a little more, and maybe not necessarily just a little more, because now this size has become almost the same as the original it's starting to look like, right? Which means the next piece I'm adding is almost twice of this already, of what I was adding in the beginning. So the compound interest builds up really quickly. Whereas simple interest adds consistently. So this is one visualization of simple and compound interest that you can even do. Right? You can cut and you can make and so on. With clay or something like that. The second you can do is graphically. So if you draw the simple interest, this is compound interest. So the other is graphical. So in the sense that you can just have years in the x-axis, 1 year, 2 year, 3 year, 4 year, 5 year, 6 year, 7 year, like that. And then you can just have the amount. So a simple interest will be a straight line. Yeah. So probably not like that, because it won't be starting with 0. It will start at the principal. It will be a straight line there. So consistently every time you step 1 year, you add the same amount. And so on. So that slope, of course, is your interest. So now, when we talk about compound interest, then our graph is going to be different. It's going to initially build up slowly, but then it's going to take off. So it's like an exponential characteristic. So if you do the same as a function of time, you're going to see that the steps that we are adding, right, is small in the beginning, but it keeps growing. So these are two kinds of visualizations you can do for simple and compound interest to try to get a sense of what's happening. So if you are aware of arithmetic progression and geometric progression, then simple interest is basically an AP, because you add the same amount every time. And the geometric progression you are adding is the compound interest is like a GP. It's a geometric progression because you are adding for a percentage of the total each time.